Hi everybody. In this video, I want to talk about classes and dynamic memory. So basically, right, we've studied dynamic memory a lot in these videos. And the main thing to think about is the fact that we have static memory is the normal memory that we work with. Static memory is where you know the variable at compile time, the data type, and how much you're going to need. And so the compiler puts it on the stack and it allocates it just great. Dynamic memory, on the other hand, is where we don't know how much memory we're going to need for it. So we use the new operator to create it at runtime. And so that allows us to change how much memory, so how many elements in an array that we're going to need or whatever that it is. So we do that at runtime. And the benefit of that, it puts it on the heap, but the benefit of it, right, is that we get to have a variable and we could only use the memory that we need, right? So we don't have to make 100 elements and we're only going to use 5 of them, right? We can do 5 and then say later on, oh, we need to expand it to 20. Then we could redo the dynamic array and add the extras. So we could do the same thing with classes, and classes have an added benefit that classes can change things up because we have a parent and child class. It kind of goes with the polymorphism, right? And that we can have the parent class be, so you can see here in my example on the right, I have a computer with a pointer to inventory, right? So my variable name is inventory, and I made it an array of 5 elements. And so I could set up each individual element in that array as a new class. So say the laptop or a desktop, right? We haven't made desktops yet in these videos, but you can kind of see the point that you would have these, right? Where that means that the behavior of a laptop is going to be slightly different. It's going to have different properties and different information than is needed than a desktop computer. And so having those in there is, it just makes it a little nicer and lets you have different behavior for different elements in your array. Now, something to note here is that you do still want to, if you use dynamic memory and you use new to allocate new memory, you still have to delete it. And if you have an array, you're going to need to use the square brackets. We have an array here, but we did the new in single objects, right? Because it's just new laptop. It's not a new array of laptops. It's just one single laptop. And so we would only have to delete each individual item. So I gave you a cleanup little sample here. So I want to demo some of this. So what we're going to do is we're going to do a computer and an inventory, and we're going to have it be with 5 elements. And then we're just going to make one of our inventory 0. We're going to make it a new laptop. Right? And what we want to do with this, right, is we are going to make sure that we delete. So we'll do our for int I equals 0 while I is less than 5, I plus plus, and then we're going to just delete the inventory. And we don't need the curly braces here, but we're going to put it in just to make sure. So that's just good practice, is when you create something to make sure you go and clean it up afterwards. So we could do this and we could execute it and make sure that it runs. I always like to make sure things run. And so you can see we got everything printed, and we're having it's not happy because we didn't actually make all the ones that we did. So let's just make them. And I don't have a desktop right now, so that's why. So now, because it doesn't like us deleting things that we didn't actually make. So now we've made them and we have there. All right. Now what we want to talk about is virtual functions. And so the issue with this, right, is now that we've made this inventory that is computers and we set them up as laptops, if we wanted to, we could just have a function in our computer, right, that is our void print, right? And we could have that, and we could come over here and make our void computer to tell it the scope, and then we have print, and we could just have it print out things, right? So standard cout print, or no, we'd want the computer is, and we put name, right? So now that's just a regular print. And if we wanted to, we go back to our main, we could just have, we could copy this for loop, and we could print out each one of our inventory. So inventory sub I dot print. And this will go through and print out, if I, and I will tell you, I always get thrown off by this, but you'll see here that it's saying that there's an error and it's not happy with my dot here. So I always get confused with, do I need a dot or do I need an arrow? Sometimes I let the compiler tell me. Now it's telling me, it's like, oh, you needed an arrow. And so now I put an arrow in there and it works fine. But so you could say, like, right, all of the computers have this name, this PC. We didn't make it change anything. So, but it prints it all out, right? Well, maybe we want it to act differently if it is a laptop. And so we could have a different print in laptop. So we'll go over to our things and we can make the same print here. And we can have laptop, and we could come over here and we can try laptop print. And I need the void here. And we could do standard cout. This is a laptop. And it won't let me print name because that's that is private. Sorry, that word just escaped me for a minute. So now we're going to try it again. Compile and see if it changed. You notice that it didn't change what it printed, even though we made this print function here. Because these are the inventory is a computer, it is using the computer's version of print. If we wanted to use the laptop's version of print, what we need to do is make the computer's version of print a virtual function. And so let's look at virtual functions. So a virtual function is basically a keyword that you add that tells the system that if a child has the same function, you want it to override that the function. So you add virtual to the parent class and you add override to the child class. And so that way it will use the one that you want it to use. So if we come back in here and we go to our header file, we are going to add override to the header file, and we're going to go to computer and add virtual to the parent class. And so you can see now that the red squiggly line went away, so it's happier about it now. So now when we compile and run, you'll see that all of them printed laptop. Now if we go back to our main and we change some of these to computer, we can try running it again. And so you can see, right, this is a laptop, the computer is, this is a laptop, the computer is, right? So it works that way. So the print still works, the virtual print function still works for the computer, but it doesn't necessarily have to work for the laptop because we have a different print for the laptop. So that is dynamic memory and virtual functions with classes.